Hello all. Today we are solving LeetCode problem number 3418, maximum amount of money robot can earn. So you are given a m cross n grid. A robot start as the at the top left corner of the grid, which is 0 0 position, and wants to reach the bottom, which is m minus 1 and n minus 1 position. So based on the grid, so robot can move either right or down at any point of time. The grid combines a value uh, coins, which is ij, and in which is given in each cell. So if coin of ij is greater than 0 or greater than or equal to 0, which means the robot gains many coins actually. If it is less than 0, the robot encounter a robber and robber steals the absolute value, which means it steals all the given value which is given as a negative number, right? And the robot has special ability to neutralize robbers at most two cells actually. So whenever the robot encounters the robbers, it has two ability to neutralize. So which means you will get you will lose zero amount of coins whichever you have collected so far. So note that robot total coins can be negative. Okay, so return the maximum profit of the robot can gain on the route actually. So we have to start from 0 0 position all the way to n minus 1 and m minus 1 position, right? And by this way, there can be any way actually. So the path we have to find, and the path which gives maximum profit, that is what we have to return. This is simple unless we are finding a, this is hard actually. So unless we are finding a way for solving this particular problem, because it is a straight very easy problem based on these two things actually. So the movement of right and movement of down, that is easy to solve, but we have to handle this neutralizing part actually. So that is where the trick comes in. So let us understand by the example about the problem. So we are having okay, so this should be 0 1 -1 and 1 -2 and 3 2 3 and 4. So based on this, the robot, we will start here, so we can go here, so which is 1, and these two are -2 and -3. So what we can do is we can go here, so we can use 1 neutralize here, so this will be 0, and we can come down and down. So 3 plus 4, which is equal to 8. So I believe this is the maximum path which you can get. Yeah, the output is 8 here. So this is a path which gives the maximum and maximum profit actually. So by this path we are neutralizing only one time, right? So here it is given us at most two cells actually. So in at most two cells, so this means the neutralizing can be done 0 times or 1 time or 2 time. So you have three possibilities, right? Also you have the decision making thing, that is move right or move down. So which means you have so many sub problems to be solved. So which gives us a hint to be to approach this problem in dynamic programming. And that is what exactly we are going to solve this with the idea which we are going to solve this problem by using dynamic programming. So here we are not using memorization, instead we are using tabulation. So we have these three problems along with these two. So we are going to consider a 3DDP. So which means for which means you will have a value for neutralizing 0 and a value for neutralizing 1 and a value for neutralizing 2. So because here by neutralizing using neutralize only one times you are getting maximum profit, right? So if it is 0, what will be the profit? It will be 7. And if it is 2, what will be the profit actually? So you cannot do 2 here. So what will be the profit? Or you can do 2 actually. So if you're neutralizing this, for example, if this part is neutralized, so it can be 4, I mean it's 5, right? So maximum among these three values, there can be whatever value, right? So in that case, you have to track all these things. So also based on the decision, you have to move right and down. So you will need the ideal 2D matrix to track all these things, right? So along with that, you have three decisions. So that is why we are using a 3D DP to solve this particular problem. So we will understand this problem with the help of one example, which is we will have the coins as 1, -3, 2, 2, 4, -1, 3, -2, and 5. So this is the problem with which we are going to solve and understand this particular problem. So based on this, actually the path gives profit. Profit is, maybe I can write it as profit, so that can be as neutralizing this, it's 4, or no, yeah, so we will come this path actually. So I believe this path, by using true neutralization, you get 10 as the value. So this is the path, yeah, so the answer should be 10. So that is what expected. So now we will construct a 3D DP array. So you will have initially infinity value, so negative infinity, and yeah, this might take some time, infinity and infinity. Or maybe we can do the small values actually. So instead of writing like this, so first thing is, initially for this value, which is dp of 0 and 0 and 0, right? So this value means you have you if for iterating, you will use I and j, and this k indicates the utmost time, which ranges from 0, 1 and 2, right? So this will have the coins of 0 value, so which is 1, so this will have 1 initially, and dp of this same value, by neutralizing 1, this will be 0. And because we are neutralizing, right, so this coin value should not be added, so dp of 0, 0 and 2 also be 0 initially. So now it's time to process the cell 0, 1, right? So which means this particular value. So now it's time to calculate the k is equal to 0 part. So you will have three values. So first we'll calculate this, followed by this, and followed by this. So here k will be equal to 0, k will be equal to 1, and k will be equal to 2. So three processing. So for k is equal to 0, what we will do is we will add the accumulated value, right? So we will take from left, so we are moving left, so the decision is left for the 0th row. So 0th row, you have to calculate only, not left actually, right. So you have to calculate the right path, and 0th column, you have to calculate the down. And things will change when you are encountering this particular area. So that is what we are going to see now. So in terms of k is equal to 0, so the accumulated value you take from left, which is dp of 0, 0 and 0, which is equal to 1 actually. So you have 1, and this will be added with the current coin value, so which is -3. So you get 1 minus 3 added actually. So sorry, I missed it. So which will result in -2. And now what you do is you will find k is equal to 1, right? So from the left, if you take dp of 0, 0 and 1, in this case this is 0 as given here, so you will have 0, so which will be again added with the coin. So 0 added with -3 gives you -3. So now what to do here is, we know that there can be one more option, because instead of considering this value we can compare that with dp of 0, 0, 0, actually, I mean without doing the neutralizing part, right? So in that case you will compare this with dp of 0, 0 and 0. So maximum among these you will consider as the value, and you will add it to this particular position. So this value is 1, so maximum of -3 and 1, you prefer this as the value, right? So because when we moving to the next step we try to avoid, we always focus on getting the maximum value out of all the possibilities, right? So that is why this value will be updated as 1, and for k is equal to 2, again dp of 0, 0 and 2, which is nothing but 0, and which will be added with -3, you get -3 again. And now you look in the left and you get the value from the left. So what exactly is in left? So it is dp of 0, 0 and 1, right? So we always try to update the value by looking into the left, actually. So that is why you have this as 0, and compare with -3 and this 0, which is the maximum value. Of course 0 is the maximum value. So what happens here is you get three values formed: dp of 0, 1 and 0 as -2, and dp of 0, 1 and this is 1 as 1, and dp of 0, 1 and 2 as 2. So this can be, you can have it as dp of 0 and 1 as the array -2, 1, this is 0 actually, so 0. So this is the value which you are getting out of this particular, based on the operation which we have done, right? And now moving to cell 2, repeating the same thing actually, but in this case we will consider this value actually. So because we have to look in the left, right? So the immediate left is these three values, so this is what we are going to use it here. So k equal to 0, from the left you have to take it, so which is nothing but -2, so -2 which is added with the coin value, which is +2. So you will add to the coin value, so you get 0. And for k equal to 1, again you take it from the left, which is 1, 1, so you have 1 added with 2, so you get 3, right? So this will be the positive, this is the greater value, because you can see that there is only zeros and negative values previous, so this will be the maximum, so we pick up this, we consider this as the maximum. So I'm going fast. So now k is equal to 2. So now what we do is, again we will consider this value, which is 0, so 0 added with 2, so 0 plus 2 is 2, right? And from the left, if you are taking it, we get this is for just an example if I'm saying. So from the left, if you are looking at, so this will be for, this is for k is equal to 2, right? So then, which means standing at this from the left is this, so the value is 1, so you have to compare with 1. So 2 and 1, which is the maximum, 2, so you take this. So now dp of 0 and 2, you get it as 0, 3 and 2. Yeah, so now this value is formed, right? So you have three values formed, that is dp of 0, 0, to dp of 0 2. It's done. So we are moving to the column actually. So now we have to look up top actually. So because we are going down, so we have to look top. So now for cell, this will be 1 0. Yes, for 1 0, what happens is you have k is equal to 0. So you look at the top. So what is exactly at top actually? So in this case it will be 0 0, right? Because 0 0 is 0 0 and 0 actually. So dp of 0 0 0 is at the top. Oops, yeah, this will be at the top. So this is what we are going to use as the reference value. So now from the top, if you take, so that was, where is that, 1 0 0. So let me write it down here. So this is 1 0 0. So you will have and the coin value also, I forgot actually. So what's the coin value, which is -2, and next one is 4 actually. So okay, so the coin value is -2. So now for k is equal to 0, so dp of this 0 0 0 value, so which is nothing but 1, and added with -2 you get -1. Okay, so k is equal to 1. So again you have to take it from the above, so which means this 0, so 0 added with -2, which is -2, and you have to see the next value to compare it actually, so which is nothing but dp of this value, which has 1. So among these you take 1. Now k is equal to 2. You have again 0 added with -2, which is -2, and now you have to look left, which is this value, right? So which is 0. So among these 0, so the new value formed is -1 1 and 0. So now comes the tricky part. We have to check, I mean look into that and how things are done. So this is where both two paths comes in, the down one and the right one, right? So now for cell 1 1 and the coin value is 4. So and for looking left we will consider this, and looking top we will have 1, actually 0 1 and 1 0. So that is what we are going to use it. So for k is equal to 0 part, let me write it down all the values. So for 1 0 it is -1 1 0. So this will have, let me erase it, 0 1 and 1 0. So 1 0 it is -1 1 and 0, right? And for this one dp of 1, it's -2 1 0. So these two are the values which we are going to use. So from the above we will, for k is equal to 0, from the above we will take for this one, right? So what is exactly in the above? You have this one, hold on, yes, from the above you will take this, and from the no, from the left you will take this, and from the above you will take this. So from the above, if you take that, you will get uh, -1 added with 4, which is equal to 3, and this one result in -2 plus 4, which results in 2. So among this you pick up 3, and k is equal to 1. So from the left you 1, so 1 you take it and add with 4, right? So which you will get as 5, and looking at this also it is 1, right? So this will be again yeah, this will be again 5, so which means you have 1 plus 4 is equal to 5. So again now you have two more operations, because you have to look left, and you have to, this have to look top. So by looking in the left, which is nothing but standing at this position, so looking at the left means the previous value, which is -2, and for this the previous value is -1. So -2, -1. So among this you choose 5, right? And k is equal to 2. So from the above, so now 0 and 0, so 0 added with 4 is 4, and 0 added with 4 is again 4. So now you have to look into the previous value, which is 1 and 1. So you have 1 and 1, so among this you will pick up 4. So you have 4 process actually. So when you are coming into the middle cell, so unless you are in 0th row and 0th column, there is no issues. You have only either right or down. When you are entering into the mid cell, you have 4 operations. So here you have 2 operations, and here you have 2 operations. So coming into this particular area, you have 4 operations to be done. So that is what the observation we are inferring from here is. So now dp of 1 1, you get 3 5 and 4, right? So we will repeat the same thing until we reach end. And just for note, so in the cell dp of 2 and 2, you will get 7 9 and 10 as the output. So out of which you will choose the maximum among all these three values, 7 9 and 10, so which is nothing but 10, and 10 is the output. So you have to construct the dp in this way, and you will get the answer as 10 in the end, right? So the time complexity for this is, you have k, which changes from 0 to 2. So n star m with k, which is k is equal to 2. So this is the time complexity taken to complete this problem. So with this idea, let us go ahead and code this up. So we start with finding n and m, and n is equal to length of coins, then m is equal to length of coins of 0, and now we have to create the 3D dp array, which is initialized with negative infinity. So dp is equal to, we will create float of -inf, yeah, and this is the array, and this is, we will have 3 values, so which is for I in range, and this for m times you create this array actually. So and then this will be wrapped up by the next array. So yeah, so now you will have for I in range, and this is still n times. So we have created the 3D dp array, and now we have to initialize the value. So now we will have dp of 0 0 and 0, and let me copy it, because we have to initialize the first initial position, right? So this will be coins of 0 and 0, and the next one is 1 and 2. Yes, so this will be 0 and 0 initially. So that is it. So now we have to start iterating. So for I in range times n, and for j in range times m, then for k in range times 3, because in Python it is non-inclusive, so we are iterating at most 2 times. So that is the reason k is 3. So now we are handling for only if you are coming from the top and there is no neutralization. So if I, then we have dp of I, j and k. So let me copy this, is equal to maximum of dp of the value, the current value, and dp of I minus 1 actually, and which will be added with the accumulated value, right? So this is I minus 1, and which will be added with coins of ij. So this is this case, for this case, and if neutralization is done, so if I and k, so in this case you will have the value as max of the current value, and this will be found by dp of the previous one, right? So dp of yeah, I think, yeah, so dp of k minus 1 and I minus 1. So this is it, and now we have to check if we are coming from the left, right? So yeah, so no, j for top and I is for row actually, so this is for column. So if we are coming from the top, so if j, I'm so sorry about the confusion, so yes, so if this will be equal to the same idea, but this will be j minus 1, and that is only one difference. So yes, yeah, I forgot this. Yeah, max of this is it's not I minus 1, it's j minus 1, the previous top actually. So, and this will be added with the coins of ij, and the same thing is repeated for the next one if it is neutralization is done. So j and k, so this will be k minus 1 and j minus 1. So that is it, and we are done with the operations. So now we are coming out of the loop and return the dp is formed, right? So now we will return max of the dp, the last dp values actually. So dp of n minus 1 and m minus 1. So the maximum value which is found in this among these three values, right? So that is it. So let us run it and submit it, and there you go. Thank you.